Hi, welcome. Today we're going to be talking about 1.1. 1.1 is real numbers. We're going to be talking about the names of what we call these numbers. These numbers are very, very important in the sense that you want to know what we call them. Okay. Um, let's go ahead and start with natural numbers. Natural numbers is basically what you teach a kid when it's born. Usually, when a kid is born and as the baby is growing up, you don't tell the baby as it's growing up, oh, you're going to turn 0 years. You start telling the baby, oh, you're going to turn 1 year, and then you're going to turn two. You're going to come close to three, and so forth. And so basically, your natural numbers is just that list. So I'm going to use braces. And so this is the number one, and two, and three, and four, comma, 5 and 6, 7, etc. Three dots and then right braces. That's the list of natural numbers. You just gotta know that those numbers is what we call natural numbers. Now, what are whole numbers? Well, whole numbers is we only add the zero in the front. Zero, then one, then two, then three, then four, and five, and six, and seven, and then we add three dots. We add the three dots just to let you know that the list continues forever. Add braces. We move on to the integers. The integers is a list of positive and negative numbers, including the zero. So in this case, we're going to put braces, and then we're going to put three dots, and then we're going to put a comma, and I can start with any of the negative numbers that you like. So let's go ahead and do -5, comma, -4, comma, -3, comma, -2, comma, -1, 0, 1, 2, 3, 4, 5, three dots, as you can see, put braces. The list of integers is very lengthy. We wouldn't be able to fit it in the screen. Okay, let's go ahead and move on to rational numbers. We called a number to be a rational number if you can write the rational number as a fraction. Okay, I don't know if you want to write somewhere on your notes or your paper. If it's possible to write it down as a fraction, that's basically what a rational number is. Let's go ahead and start with the first one. Okay, I'm going to give you the number 1/2. Okay, 1/2, it's considered to be a rational number. But look at this number, 1/2, it's also a decimal number, it's 0.5. So 0.5, even though it's a decimal number, it is possible to write it down as a fraction. This is the reason why it's called a rational number. What about the number 8? Well, the number 8 can also be written down as a fraction. It's 8/1. Okay. Basically, any whole number can be written as a fraction. A whole number will also be considered to be a rational number. Okay. What if I give you, let's just say 0.25? Remember, 0.25 is also considered to be a rational number because this is 1/4, etc. So you can write a number in a fraction form, then that is going to be considered to be a rational number. What's an irrational number? An irrational number is a number that it's impossible for you to write as a fraction. Okay, so for example, if I was to give you, using your calculator, you guys have a symbol that it's called pi. Okay, which is this one, looks like this. So if you put it into the calculator, this one gives you 3.14, and then 1.5, and then 9, and then 2.654. This number is not really possible to write it down as a fraction. As you can see, it never stops. So this symbol that it's called pi, it's called an irrational number. Okay, here's another example. What if I give you the square root of 5? If I was to put it into the calculator just to find what the answer is, This is going to give me a bunch of decimal numbers. It's going to give me 2 point, then 2, 3, 6, 0, 6, 7, 9, 7, 7. And so you can see that it will not be possible for me to write it down as a fraction. Okay, I'm going to remove complex numbers. We're going to come back to complex numbers at a later time. But complex numbers, basically, it's a bigger group. Now, you can think of whatever I am doing right now as if you were to be wearing shoes, okay? So this is what I usually tell the students. You can think of, but by the way, we use the symbol for the natural numbers. We use like an N like this. And then we use the whole numbers. We use like a W. And then we use the integers. We use like a Z. We use the rational numbers. I'm sorry, erase that R. I don't remember the symbol for the rational numbers. We use these complex numbers. We use the C like this. And all of these numbers, all of them are, I'm sorry, remove the complex. Let me go ahead and remove my little circle here. All of these numbers right here that we have, without including the complex numbers, they're all called real numbers. Okay, in order to write the word real numbers, we just use this R. This R represents real numbers. They're all of them real numbers. However, complex numbers are a bigger set. In fact, complex numbers include all the real numbers plus the complex numbers. When we get to that point, we're going to discuss it more in detail. I don't remember what the symbol is for rational numbers, but you don't have to worry about the symbol. Okay. Now, I was telling you about the shoe size. So think like this. Think like when somebody is born, they use some sort of a shoe size. That shoe size, you can take it as being the natural numbers. It's like teaching the kid, you're 1 year, you're going to turn 2, you're going to turn 3, and so forth. As their feet starts to grow, they gotta change the shoe size. The shoe size now it's going to get bigger. That bigger is going to turn into the whole number. Okay. And so the whole number is adding the 0. Okay. And then as your knowledge you get bigger, you're going to change your shoe size to something bigger. And that's going to be your integers, etc., etc. That's basically as the way you can see this is like your knowledge is growing. Okay, let's go ahead and do this example right here that I have. It says, go ahead and classify the numbers as natural, whole, integer, rational, or irrational. Basically, what you want to do is you want to decide what kind is it. Okay, so I'm going to place a little check mark or a little dot. So I can see 1/2. 1/2, it's a fraction. Since 1/2, it's a fraction, then that represents a rational number, yeah? 1/2 represents a rational number. Yeah, this will be okay. So I'm gonna put a check mark right here. Okay, it's a rational number, it's a fraction, but it's also considered to be a real number. Okay, not a natural number. Now I'm gonna move on to the square root of 2. The square root of 2, I don't know what it is, but if I put it into the calculator, that's going to give me a decimal that I cannot write as a fraction. So that's going to be an irrational right here. That's also going to be part of a real number. Okay, and that's it. Okay, I'm going to move on to -5. And I can see that -5, it's in here. I don't know if you guys can see it. Let me go ahead and try to highlight with purple. I can see -5 right there. It's part of my integers. But then -5 could also be considered to be a rational number since I can write this 8 as a fraction. I can also write the -5 as a fraction. Okay, So then that would be a integer. That's also going to be considered to be a rational number because I can write it down as a fraction. And then that it's also a real number. Okay, I'm going to move on to 0.25. 0.25, it's a decimal number. And I can see that the decimal number represents a rational number. And this rational number, it's also a real number. Okay, what about 7? Well, 7, it's part of my natural numbers. Let me see if I can use a different highlighter here. I'll go ahead and use blue. And I can see here 7 is right there. It's part of my natural numbers. And then I can see 7, it's also part of the whole numbers. And I can see that 7, it's going to be somewhere in here, and it's going to be part of my integers. And I can see that 7, I can also write it down as a fraction. And then that will be it. Okay. So then I can see that 7, it's considered a natural number. It's considered a whole number. It's considered an integer. It's considered to be irrational. And then it's a real number. The only thing that it is not, it's an irrational number. Okay, that's it. This is what you're going to be doing in WebAssign. WebAssign is going to give you some sort of numbers, and they're going to be asking you, is this number a natural number, a whole number, an integer, or it's going to tell you, go ahead and decide what type of a number this is. And you just have to label the type of number that you have. Okay, let me go ahead and move on to example 2. Order the numbers from least to greatest, okay, or from smallest to largest, okay. So this is what I'm going to do right here. So what I'm going to do is I'm going to change everything into decimals, and then I'm going to compare. So then I can see that the 1/2, I can change the 1/2 as 0.5. And then I can write the square root of 2 into the calculator, and I can see that the square root of 2 represents like a 1.4142, and then I have a lot more decimals. And then I'm going to keep the -5 the way it is. And then I have the 0.25. And then I have the 7. Okay, from here, I'm going to decide which one's the smallest number. Well, the smallest number is any number that it's negative. Now, sometimes students kind of struggle. So let me go ahead and draw a number line. So if I was to draw a number line, if I was to label 0 here, and I write all the positive numbers to the right, like 1 and 2 and 3, all of the positive numbers will be to the right of 0. And then I have a -1, then I have a -2, and then I have a -3, and then I have a -4. By the way, this is not drawn to scale. Then you can see all the negative numbers on the left side. Okay. Over here on the right side, they're all the positive numbers. And on the left side, we have all the negative numbers. Well, this is the negative. This is the positive. Of course, the positive, it's going to be bigger than the negative. You might think as the negative as money that you owe people. Okay, so if I think in that way, then I can see that -5 will be the smallest one. Excuse me. So that will be the smallest one. So this will be -5. Then the next number that is the smallest one, I'm going to compare them. Okay, I have 2 decimal numbers. I have one of the decimal numbers is 0.25 and then 0.5. And I can see that 0.25 is smaller than 0.5. Now you got to write the numbers in its original form. Okay, so I'm going to keep the 0.25 And then I'm going to write the 0.5, but instead of writing 0.5, I'm going to write it down as 1/2. And then I'm going to compare the next two so then I can see that 1 point, I'm sorry, go ahead and erase this. I said we're going to use the original. And so then I can see here that this one belongs to the radical 2. So then I'm going to write it down as the radical 2 and then 7. And so this will be my answer. This will be considered to be my answer. And you can see that we have ordered the numbers from smallest to largest. Okay, here are just some properties that you have to know. We have something that is called the additive and multiplicative identities and inverses. And basically, the additive inverse says if you add two numbers, one where it's positive and one where it's negative, of course they're going to cancel out. Because if I have 5 plus a -5, then they're going to cancel out. Additive identity, it's 18 plus 0 is equal to 18. In math, we write it down as a plus 0 is equal to 8 because a represents any number. In this case, I gave you the example already as 18 plus 0, but what if I give you 5 plus 0 is equal to 5? What if I give you a -3 plus 0 is equal to a -3? Multiplicative identity says if you multiply any number times 1 is equal to that number back. Multiplicative inverse says if you multiply the fraction times basically the reciprocal of that fraction, it's always equal to 1. Okay? And that's basically it. You just have to be able to understand the names. Let's go ahead and move on to mathematical properties. We have the commutative property of addition. Now, the following properties are super important, not in 1.1, but later on. We have something that's called a commutative property. The commutative property says, okay, if I add two numbers together, let me call those numbers a plus b. And if I switch them, the sum should not change. Here's an example. If I give you 2 plus 3, we know that 2 plus 3 is equal to 5. But if I switch them, 3 plus 2, the sum will still be 5. Okay, that's what we call a commutative property. Okay. We have commutative property of multiplication. The commutative property of multiplication says if I multiply two numbers together, let me go ahead and call those two numbers a times b, and if I switch them, the product should not change. Okay, I'll go ahead and give you an example over here. So my example will be, for example, 2 times 3 is 6, and 3 times 2 it's also equal to 6. I'm sorry, not a decimal, okay? Can you write that little dot as 3 times 2? Associative property of addition says if I have three numbers and I'm going to add all three numbers together. So let's just say, let me go ahead and zoom in here. So I have three of them. I have A plus B plus C. Let me go ahead and write it down again. If I add them, but if I want to add them in a specific order, okay? So let's just say I wanted it to do A plus B first, A plus B, and then plus C. This will be the same as A. What if I want to do B plus C first? Notice I did not move the numbers at all. The only thing that I did is I regrouped them in a different form. And that's the only thing that I would like you to pay attention to. It's the regrouping part, not moving the numbers around like the commutative property. Okay, here's an example. Suppose I give you 2 plus 3 and then plus 4. This should be the same as 2 and then plus 3 plus 4. You can try it to see if it works. Well, 2 plus 3 is 5, and 5 plus 4 gives me a 9. I can do the other side. So this side is like a 9. I can do the other side. 3 plus 4 is 7, and 7 plus 2 is equal to 9. So then you can see that it works. But I did not move the numbers at all. I only grouped them in a different form. Okay, associative property of multiplication says if I have three numbers and I only group them in a different form, so then I can do A times B and then times C, it's equal to A and then B and C. Once again, I can multiply them. I can do 2 times 3 and then times 4, or I can do, let me go ahead and erase that parentheses. We can do 2 and then 3 and 4 here. 2 times 3 is 6, and 6 times 4 is 24. I can do 3 times 4 is 12, 12 times 2 is 24. So you can see that the product's not going to change. Last, I need the distributive property. The distributive property says if I have a combination of addition and multiplication. So let me go ahead and write it down in a different color. So suppose I have A, and then I have a combination of B plus C. Well, what you're going to do if you have a combination, you are going to distribute. You are going to multiply A times B and then plus A times C. Now, if this is a minus, you're going to do the same thing. It will just be AB minus AC. Okay, that's what we call distributive property. Okay, right here, the only thing that you have to do is you just have to identify what type of property are we using. Fill in the blank with the adequate property. So I have 43 plus 25. It's equal to 25 plus 43. So in this case is you kind of have to observe all of the properties that you have on the paper, and you have to decide what type of a property do you have. So I hope you guys can see that this one will be considered to be commutative property. So this is a commutative property of addition. Then we have 8 times 5 and then times 10, or 8 times and then 5 times 10. And you can see that this is the associative property of multiplication. Okay, let me see. 5 plus parentheses is 6 plus 2. It's equal to 5 plus 6 and then plus 2. You can see that the numbers did not move, only the grouping changed. So then I can see that this is associative property of addition. Uh, 12 times 5, it's equal to 5 times 12. I have moved them around. The numbers, I'm moving them, but the product's not going to change. So this is commutative property of multiplication. And then we have the last one, 4, then parentheses, 5 plus 3. You can see that this is like distributive right here. I am going to multiply that 4 times that 5, and I get 4 times 5. I'm going to distribute the 4 times that 3, and I get 4 times 3. So this one's very obvious that this one's distributive property. Once again, this is basically what you're going to be doing on WebAssign. You're just going to be identifying what kind of a property do you have, and you just have to observe it. Let's go ahead and talk about absolute value, and we're almost done with 1.1. Okay, absolute value. What is absolute value? Well, absolute value is what we call the symbol here. So the symbol right here that you see, those lines right here, it's what we call the absolute value. Okay, so this is what we call the absolute value, are the lines on the outside. And basically what they define or what they describe is the distance from 0 on a number line to a number. Okay. So for example, I have the number line here, it's 0. Once again, it's not going to be drawn to scale. But let's just say this is the number 1, and this is the number 2, and this is the number 3. And of course, we have more numbers. This is -1, and this is -2, and this is -3. And of course, we have more numbers. But let's just say I wanted it to know the distance from 0 to 2. And you can see that the distance will be 2. Now, in order for me to write it down, I'm going to write it down in mathematic form. So I'm going to say absolute value of 2. Absolute value of 2 means what's the distance on the number line from 0 to 2? And so then you're just going to say it's 2. I can also give you absolute value of -3. If I ask you for the absolute value of -3, then basically you got to say what's the distance from 0 to -3. And then you can say, well, the distance from 0 to -3 is 3. Okay, this is the exact definition or the precise definition. What this says, it says if the absolute value of a positive number. So this one's positive. So it's letting you know that x is positive. X is positive, we're talking about like that 2 is positive. But then what if it's the x is negative inside? So x is to the left of your number line. And so this is the negative that you see here. Okay. Okay, so then let's go ahead and do examples here. Absolute value of -5. Well, the distance from 0 to -5 is just 5. Absolute value of 5, well, the distance from 0 to 5 is just 5. Look at the next example, it's a little bit different. In order for you to do the next example, the first thing that you need to do is you got to do the inside in the absolute value. So for a moment, let me go ahead and re-highlight. You are only going to do the inside, this part right here. Do that part without the absolute values. So in this case, it's going to be, well, 7 minus 5, that will give you a 2. Notice that I'm writing down the absolute value of 2, then plus 2. Now you're going to take the absolute value of the whole thing. Okay, so now the absolute value of 2, it's 2, then plus 2, that's equal to 4. Okay. Okay, let's go ahead and do the inside in here also, only the inside. Okay, so notice that I'm gonna keep the absolute value. So then that will be the inside, I gotta do the square first. So this would be -2, then 3 squared is 9. And then keep this. Okay, I'm still not done inside. I gotta do the inside first, okay. Okay, I have -2 plus 9. Well, that would be 7. Okay, I gotta do now the absolute value. So now I'm going to take the entire thing, absolute value of 7, and I will also do the absolute value of -3. So this is going to be 7. Absolute value of -3 is 3. Go ahead and observe this one. This one represents your operation symbol. So the operation symbol doesn't change. Okay, 7 minus 3 is equal to 4. And so that will be your answer. Let's go ahead and do the last one. Okay, so then for the last one, there's really nothing to do inside our absolute value. So now we are only going to find the absolute value of -7. Well, absolute value of -7, it's 7, but I'm going to take or drop my symbol. So this will be a negative plus that 3. Okay, now -7 plus 3, well, that would give me a -4. So then that would be the answer. Okay, so as you can see, I am completely done with section 1.1. This is all you need to know for this section. If you have any questions, please go ahead and let me know. And if not, I will see you next time, okay? Bye, have a great day.